Imagine, right, you're looking at an X-ray of a broken arm.
Yeah, we've all seen one of those.
Right. And there's that stark, jagged white line cutting right across the dark image of the bone. It's obvious. The doctor points to it, you nod, they put a cast on it, and you walk out with like a timeline for healing.
It's very visible, very binary, broken or not broken.
Exactly. The path forward is clean. But when you step into the world of neurodevelopment, and specifically into the lived daily reality of PURA syndrome, that X-ray machine is, well, it's entirely useless.
Totally useless. You're looking at a diagnostic landscape that is completely murky.
Murky is the perfect word for it. The lines are never clean, and the textbooks often lag, years behind what is actually happening in a family's living room. So welcome to this deep dive.
Glad to be here.
If you are listening to this, it is because you know that murky landscape better than anyone on Earth. This deep dive is custom tailored for you. The parents, the carers, the siblings, and the absolute champions of children diagnosed with PURA.
And, navigating that landscape requires an entirely different set of tools than what you get at a standard pediatrician's office.
Right, which is why our mission today is all about celebrating Inchstones, redefining success.
I love that concept. Inchstones instead of milestones.
Yeah, we are taking a vast amount of medical literature, clinical guidelines, and educational advocacy resources and distilling them all down, basically to validate the reality you live every single day.
Because in the PURA world, typical developmental milestones, they just simply do not apply.
No, they don't. A thumb wiggle is a party in this community. A sustained gaze or a new vocalized sound, those aren't just like emotional victories, they're profound.
They are profound physiological triumphs. And we're going to look at the hard science of exactly why that is today.
So let's start with the timeline, because I think it explains so much about why families feel like they're constantly explaining this condition to medical professionals.
Oh, they are? Every time they go to the ER or a new clinic?
Right. So when did the medical community even start naming this? Obviously, the condition has existed for as long as human genetics have existed, but when did we actually put a pin in the map and say, okay, this is PURA syndrome?
It is shockingly recent. October 23, 2014.
Wow, 2014.
Yeah, that is the exact date the first clinical paper officially recognizing PURA syndrome was published.
That's practically yesterday in medical terms.
It really is. It was spearheaded by a team led by Dr. David Hunt in the UK. And then almost simultaneously, Dr. Seema Lalani's team published similar findings over in the US.
So before the fall of 2014, this diagnosis literally did not exist in any medical literature anywhere.
Nowhere. If you have an older teenager with PURA today, they were literally born into a world where their condition legally and medically had no name.
That is wild. Why the delay, though? Why did it take until 2014 to figure this out?
It really comes down to the evolution of genetic testing technology. Specifically something called whole exome sequencing, or WES.
WES, okay. And before that?
Before WES became, clinically accessible and affordable around that time, geneticists were largely using targeted panels.
Which means they had to guess, right?
Exactly. They had to guess what condition a child might have based on their physical symptoms, and then they guessed specifically for those suspected genes.
And if you guess wrong?
The test comes back negative. You get nothing. And the clinical presentation of PURA overlaps so heavily with other, more well-known neurodevelopmental conditions.
So an older child with these symptoms back in, 2010 was likely handed a completely different label.
Almost certainly. Before 2014, patients presenting with profound hypotonia, so low muscle tone, and developmental delay, early respiratory issues, they were very frequently misdiagnosed.
What were they usually misdiagnosed with?
A doctor might look at the clinical picture and tell a family they were dealing with Rett syndrome, or Pitt-Hopkins, or maybe central hypoventilation syndrome.
Oh, wow. So totally different genetic paths.
Right. Some were even diagnosed with myotonic dystrophy. But the advent of whole exome sequencing allowed researchers to finally stop guessing.
Because WES looks at everything.
Exactly. It looks at all the protein coding regions of the DNA at once. And when they did that across large cohorts of undiagnosed children, this distinct mutation on the PURA gene suddenly lit up like a beacon.
Which means the actual global count of individuals with this diagnosis is incredibly small. Even if it is growing as WES becomes the standard of care now.
It's very small.
Yeah, I was looking at the registries. The initial 2014 reports were based on just 15 individual cases.
Just 15.
And as of the most recent data tracking we have, there are approximately 706 confirmed cases across more than 60 countries. So the estimated incidence is 1 in 1 millisecond.
1 in a million, yes.
For the parent listening to this right now, that rarity translates to a very isolating reality at the local clinic.
Completely isolating.
When you walk into a typical pediatrician's office or an emergency room on a Tuesday night, you are almost certainly the first and quite possibly the only PURA family that doctor will ever encounter in their entire career.
And that is the massive burden of a rare disease. The parents are forced to become the foremost experts on their child's condition. The doctors are learning from them.
Which is a heavy weight to carry.
It is. And to advocate effectively, we have to drill down into what is actually happening on a molecular level. We need to look at the biological mechanics so parents have that vocabulary.
Okay, let's do that. Let's look at the gene itself. Where exactly is this quote-unquote spelling mistake happening? The address I saw in the literature is chromosome 5, specifically the 5q31.3 locus.
Right, 5q31.3. Let's break that address down because it really helps to visualize the biology. Every typical human cell contains 46 chromosomes, arranged in 23 pairs.
One set from mom, one from dad.
Exactly. Chromosome 5 is one of the larger ones. The Q refers to the long arm of that chromosome.
Okay, so 5q means we're on the long arm of the 5th chromosome.
You got it. And the 31.3 is essentially the specific neighborhood, the street, and the exact house number on that long arm where the PURA gene lives.
Okay, so we're at the house. What does the PURA gene actually do when it's functioning typically? Like, what's its job?
Think of genes as instruction manuals. The PURA gene provides the exact biological blueprint for manufacturing a very specific protein called Pur Alpha.
Pur Alpha.
Right. Pur Alpha is what we call an RNA and DNA binding protein. This means it literally physically attaches itself to the nucleic acids in our cells to regulate how other genes are expressed.
So it's sort of a manager of other genes.
Yes. And it is a highly conserved protein.
What does highly conserved mean in genetics?
It means if you look at the Pur Alpha protein in a mouse, or even in much simpler, older organisms, it looks almost identical to the human version. Evolution does not mess with Pur Alpha.
Oh, wow. So if evolution hasn't changed it over millions of years, it must be pretty important.
Exactly. When a protein is that highly conserved, it tells biologists that it is absolutely vital for basic, fundamental cellular survival.
I was trying to picture what Pur Alpha actually does in the developing brain, and I kept coming back to the idea of an orchestra conductor.
I like that analogy.
Because if the developing brain is this massive complex symphony of billions of neurons trying to connect, Pur Alpha is the conductor standing at the podium. Normally, we have 2 copies of the PURA gene, right? So we have 2 conductors working in perfect harmony to direct all this music.
That's right.
But PURA syndrome is caused by haploinsufficiency. Haplo meaning half, insufficiency meaning not enough. So basically, one of those conductors is missing, or their baton is snapped in half.
It's a very apt visualization because the music, the biological development of the child, it doesn't stop.
Right.
The remaining conductor is still at the podium, frantically trying to direct the entire symphony. But that single conductor has to work twice as hard.
That sounds exhausting.
It is biologically exhausting. In the central nervous system, Pur Alpha is responsible for directing several really critical processes.
Right.
The proliferation of neural cells, the maturation of dendrites, which are the little branch-like structures neurons use to talk to each other, and critically, the formation of myelin.
Myelin, that's the insulation, right? The fatty coating around the nerves that allows electrical signals to travel quickly and efficiently like rubber around a copper wire.
Precisely. Without enough Pur Alpha, the biological machinery that builds that myelin is severely understaffed. The myelination process is delayed, the cytoskeletal dynamics, the literal structural scaffolding within the brain cells, they're altered.
So the single remaining conductor just cannot keep up the tempo.
No, they can't. And as a result, the entire developmental timeline slows way down.
Wait, let me push back on something here because the literature talks about a few different ways this actual mutation happens.
Sure, yeah.
You mentioned haploinsufficiency, meaning there's only half the protein available. But the most common cause is a pathogenic sequence variant, specifically one called P-phi233del.
Yes, that's the most common spelling mistake.
Right. It's described as a spelling mistake where a single amino acid is left out. But how does a spelling mistake lead to half the amount of protein? Doesn't the body just read the misspelled gene and manufacture a slightly weird mutated protein? Why is the conductor entirely missing?
That is a fantastic question, and it gets right to the heart of how protein folding works.
Okay.
Proteins are not just long, linear strings of amino acids. Their entire function depends on them folding into highly specific, incredibly complex three-dimensional shapes.
Like origami.
Exactly like origami. The Pur Alpha protein requires every single one of its amino acid building blocks to fold correctly so it can physically bind to the DNA. In the case of that variant, P233D-del, the biological machinery skips exactly one amino acid,
Just one.
a single phenylalanine at position 233.3, just one missing block out of hundreds.
That's so tiny.
It is. But because that single block is missing, the entire 3D structure of the resulting protein is ruined. It misfolds. And our cells have a very strict, rigorous quality control system, primarily utilizing something called the proteasome system.
Like a biological bouncer.
Basically, when the cell detects a misfolded, useless protein floating around, it tags it for destruction and immediately breaks it down like a garbage disposal.
Oh, I see.
So even though the mutated gene is technically trying to manufacture the protein, the cell destroys it immediately because it's defective. The end result is exactly the same. You are left with only the functional protein produced by the one healthy gene, haploinsufficiency.
Wow. Okay, and what about the other 10% of cases? Because the literature notes that a small minority are caused by full gene deletion.
In those cases, the mechanism is much more blunt.
Yeah.
A whole segment of the 5q31.3 region is just simply missing. The blueprint itself is gone.
Just erased.
Yeah. This is sometimes called the contiguous gene deletion syndrome, because neighboring genes might also be wiped out along with PURA, which can sometimes result in a slightly more severe or complex clinical presentation, depending on, what else was lost. But the primary driver of the neurodevelopmental symptoms is still that severe lack of Pur Alpha.
Okay, before we move off the molecular biology, there is a point of absolute non-negotiable validation that needs to be stated for the parents listening right now.
Yes, absolutely.
The literature is unanimous on this.
Yeah.
This condition is almost entirely caused by a de novo mutation that translates to new. It occurs totally randomly during the earliest stages of fetal development. You, as the parent listening to this, you did absolutely nothing to cause this.
Nothing at all.
There is no medication you took, no food you ate, no stress you experienced during pregnancy that triggered that spelling mistake. It is an entirely random biological lightning strike.
It is so essential to internalize that. It is a spontaneous error in DNA replication. However, and just to be scientifically thorough here, we do have to mention a very rare exception regarding the risk of recurrence in future pregnancies.
Right, something called gonadal mosaicism?
Yes.
Hold on, though. You just said this is totally random and not inherited from the parents, but now you're saying there's an exception where a parent can pass it on again. How does that work if it's not in their DNA?
It's very counterintuitive, but it has to do with how early human embryonic development works.
Okay, walk me through it.
When the parent themselves was a microscopic embryo in the womb, consisting of just a few dividing cells, a spontaneous mutation occurred in just one of those early cells.
Just one cell in the parent.
Right. As the parent continued to grow, that one mutated cell divided and eventually became the specific tissue that produces gametes, so the sperm or the eggs. So the parent is perfectly healthy. A blood test will show they do not have PURA syndrome. Their skin, their heart, their brain cells all have completely normal PURA genes, but a tiny hidden cluster of their reproductive cells carries the mutation.
So if one of those specific gametes is fertilized,
The resulting child will have PURA syndrome, and the parent theoretically carries a risk of having another child with the same condition.
because the mutation happened a generation ago, but remained completely silent until it was passed on.
Precisely. It is exceptionally rare, but it is the reason clinical geneticists will usually offer targeted testing and prenatal counseling for subsequent pregnancies, even when the parent's blood tests come back totally clear.
That makes total sense. Okay, so establishing that biological reality, this lone conductor trying to manage an incredibly complex symphony with missing materials, it helps us really contextualize the terrifying reality of a PRA child's first few weeks of life.
It is the hardest phase for so many families.
Because when these babies are born, they generally look typical. They're usually born at a normal weight, often full term. But they immediately enter what families often describe as a neonatal gauntlet.
That's a very accurate description.
You are not looking for milestones here. You are fighting for physiological survival in the NICU.
The initial clinical presentation is overwhelmingly severe. The autonomic nervous system, which governs all the basic life support functions of the body, is fundamentally dysregulated due to the lack of Pur Alpha.
The list of symptoms newborns face is harrowing. We are talking about severe hypotonia, just totally floppy, hypersomnolence, meaning the baby sleeps so constantly and so deeply that it interferes with their ability to even wake up and feed.
Right, they can't sustain wakefulness to eat.
And most dangerously, respiratory insufficiency, specifically central apnea.
Yeah, let's differentiate that from obstructive apnea, which is what most people are familiar with, like in adults who snore. Obstructive apnea is a physical blockage of the airway. Central apnea is entirely neurological. The brain stem simply fails to send the necessary chemical and electrical signals to the diaphragm.
So the baby isn't struggling against a blocked airway,
No, the brain just literally forgets to initiate the breath.
which frequently requires intubation, CPAP machines, and eventually the placement of NG tubes or permanent D tubes directly into the stomach, because the brain isn't coordinating the suck, swallow, breathe reflex at all.
Exactly. It's a massive crisis of the autonomic system.
But what really fascinates me here is the intersection between the formal medical literature and the lived experience of these families. Because the doctors, they were logging the apneas and the hypotonia, but the parents who are staring at these monitors 24/7, they started noticing anomalies that were not in the textbooks yet.
Yes. The family-reported data provided incredibly vital pieces of the clinical puzzle early on.
Two things specifically stand out from the registries. Extreme temperature instability, where the babies would inexplicably drop their body temperatures into hypothermic ranges without any environmental cause. Like the room is warm, but the baby is freezing.
Right.
And hiccups. Several mothers documented that their babies had excessive, violent hiccups while still in utero, and it just continued relentlessly after birth.
Both of those things point directly back to the brainstem and the hypothalamus.
How so?
Well, the hypothalamus acts as the body's thermostat. Without the proper cytoskeletal scaffolding and myelination to transmit sensory feedback, the thermostat is essentially broken.
So it's getting the wrong temperature readings from the body.
Exactly. It misreads the internal temperature and fails to trigger the metabolic responses needed to generate heat. And the hiccups are similarly a reflex arc governed by the brainstem.
I didn't know hiccups were a brainstem thing.
They are. And without the inhibitory control pathways that usually suppress random spasms, the vagus nerve just fires erratically, causing the diaphragm to spasm over and over.
I have to stop you there, though, because there is a glaring contradiction I am trying to wrap my head around.
Okay, what is it?
We just established that the Pur Alpha protein is missing, right? And it is missing forever. We cannot grow a new gene. So why do these terrifying, life-threatening symptoms, the central apneas, the extreme hypothermia, the inability to swallow, why do they so frequently resolve or drastically improve after the child turns 1 or 2 years old?
It's a great question.
Why does the orchestra suddenly stop missing the beat on breathing if the conductor's still gone?
It is a remarkable testament to the resilience of the human nervous system. It really comes down to the fundamental difference between brainstem maturation and higher cortical development.
Okay, break that down for me.
The brainstem, which controls those autonomic functions like breathing and temperature, is an evolutionarily ancient, highly robust piece of biological machinery. It is hardwired for survival.
Right.
Even with haploinsufficiency, even operating with only half the necessary Pur Alpha, the brainstem possesses an immense capacity for neuroplasticity.
So it eventually wires itself correctly, it just takes drastically longer.
Exactly. In a typical infant, that autonomic wiring stabilizes in a matter of weeks. In a PURA infant, the brainstem is building those life-sustaining pathways meticulously, agonizingly slowly, with half the required materials.
Like building a house with half a crew.
Yes, it might take 12 to 18 months, or even longer, but the brainstem does eventually mature enough to sustain basic autonomic homeostasis.
That reframes the entire first year of life. When a child finally weans off a breathing tube or when their temperature finally stabilizes without needing a warming blanket, that is not just the child, growing out of a phase.
No, not at all.
That is a biophysical marathon. Their nervous system fought a monumental battle to build those pathways. Surviving that neonatal gauntlet and achieving physiological stability is the ultimate Inchstone. It is a victory of internal engineering.
It really is, and it's a foundational victory, because it's only when those acute medical crises of infancy stabilize that the family and the medical team can really shift their focus to higher neurodevelopment.
Right, once they are actually surviving.
The brainstem is relatively secure, but the higher cortical areas of the brain, the parts responsible for voluntary movement, complex cognition, and expressive language, those areas require vastly more intricate networks of myelinated neurons.
And those areas are still severely lacking that Pur Alpha.
Yes, they remain profoundly impacted.
Which logically brings us to the next massive frontier for these families: communication. Once the child is breathing on their own, the natural instinct is to wait for their first words. But in the PURA world, parents have to radically redefine what talking looks like.
They absolutely do.
The data on the communication profile of PURA syndrome is stark. The vast majority of affected individuals are non-speaking or nonverbal. They remain unable to produce meaningful spoken words throughout their entire lives.
And if expressive speech does develop, it's typically limited to single words, short phrases, or very basic vocalizations.
Yeah.
But it is vital, really vital, to understand the mechanics of why this happens.
Right, it's not what people assume.
No, it's not simply a cognitive deficit. People assume they don't talk because they don't understand. But it's heavily rooted in the physical neurology of the condition, specifically dysarthria.
Dysarthria, meaning the physical inability to articulate. Because the hypertonia we saw causing the floppy limbs in the newborn, it doesn't just stay in the arms and legs, it affects the micromuscles of the face.
Yes. Speech requires an astonishingly complex coordination of the tongue, the soft palate, the lips, the jaw, and the vocal cords, driven by several different cranial nerves, all firing in perfect sequence.
It's an athletic event.
It is. And if those articulatory muscles lack resting tone, if they are fundamentally weak and hypotonic forming, the sharp, precise sounds required for human speech becomes biophysically impossible, regardless of how intelligent the child is.
That brings up the most crucial realization in the entire PURA literature, the absolute hallmark of the condition. There is a vast causous discrepancy between receptive language and expressive language.
The gap is huge.
Receptive language being what the child understands in their environment, expressive being what they can motorically produce out loud.
The clinical reports and parental observations are entirely unified on this point. These children process and understand vastly more than they can verbally express.
Their brains are absorbing everything.
Everything. The neurological pathways required for auditory processing and comprehension, which are primarily located in Wernicke's area in the brain, they seem to function at a much higher capacity than the complex motor planning required by Broca's area and the cranial nerves to output speech.
So they can follow complex commands.
Yes, they follow commands, they have very clear preferences, they possess a high degree of situational awareness, they're just trapped behind a physiological barrier.
There is a quote from the rare chromo source material we reviewed that just perfectly encapsulates this. It is from the parent of a 14-year-old boy named Aiden.
I love that quote.
The parent states, "I have learned from Aiden that being nonverbal is not the same thing as not being able to communicate." That single sentence completely shifts the paradigm of speech therapy for a PRA child.
It necessitates a total shift in clinical strategy. If the biological barrier is the physical articulation of speech, forcing a child to repeat vocal drills to strengthen hypotonic muscles, it yields very little return. It just frustrates them.
So what's the alternative?
The goal must be to bypass the biological barrier entirely using augmentative and alternative communication, or AAC.
We see this constantly in the case studies. There is a specific note about a 7-year-old girl named Sarah. Her receptive skills were excellent, but she couldn't consistently form words. And when her therapist stopped focusing on articulation and introduced a low-tech PODD communication book, alongside a high-tech electronic touchscreen device, her entire world opened up.
She found her voice.
Right, it just wasn't the biological voice she was born with.
Which is why redefining what progress looks like is so essential. Progress in communication for a PRRA child is entirely nonlinear. The Inchstones look very different.
Let's talk about what those Inchstones actually look like in the living room. It might be a vocalized mumble. To an outsider, it's just a sound. But to the parent, the act of the child intentionally drawing breath, vibrating hypotonic vocal cords, and directing a sound at a specific person to gain attention, that is a huge Inchstone.
Huge. It could be establishing sustained eye contact to indicate a yes.
Yeah.
It could be the immense physical effort of raising a hypoconic arm just to point at a desired object across the room.
Or it could be that transformative moment when they successfully navigate a tablet screen, locate the correct symbol for water, and press it.
The AAC device.
Yeah. When a child presses that cup icon on an AAC device, to the outside world, it looks like a kid pushing a button on an iPad. Big deal, right? But neurobiologically, that child just formulated a thought, translated that thought into a visual symbol, commanded a hypertonic limb to move against gravity, and executed a precise fine motor action through a nervous system that is literally fighting them at every single step.
They just ran a marathon.
Yes, they ran a marathon to tell you they are thirsty. That is not just a button push, it is the cognitive and expressive equivalent of a neurotypical child looking you in the eye and speaking their very first full, grammatically correct sentence. That is their voice.
And that precise, massive physical effort required just to push a button logically leads us into the broader reality of their gross motor skills. Because just as communication requires alternative routes and immense patience, navigating physical space demands a monumental multidisciplinary effort.
Okay, let's look at the data on physical milestones.
Okay,
Because to redefine success, we have to look the biological reality square in the face. Independent walking is heavily delayed across the board, and for a significant portion of the PURA population, it is never fully achieved.
The clinical characteristics indicate that if independent walking is achieved, the timeline is vastly stretched. We see it happening anywhere between 22 months and 7 years of age.
Wow, up to 7 years.
And crucially, when it is achieved, it is almost universally characterized by an unsteady, wide-based gait.
Why specifically a wide-based gait? Like, why not just a slower, typical walk?
It is a brilliant biomechanical adaptation driven by the cerebellum and the persistent central hypotonia. If we return to the molecular level we talked about, the delayed myelination means the electrical signals from the motor cortex to the legs are slower and far less coordinated.
The signals are lagging.
Yes. Furthermore, hypotonia means the trunk muscles, the core. They lack the inherent passive resting tension needed to keep the spine effortlessly upright against gravity.
So they are constantly fighting just to stay vertical.
Right. So to compensate for a weak core and delayed signaling, the brain instinctively tells the legs to spread wider, creating a broader base of support to prevent the child from toppling over.
I was trying to visualize the sheer physical toll this takes on the child. I know people often compare complex physical therapy to, building an airplane while flying it, but that feels like a cliche that doesn't really capture the biology.
It's a bit too simple.
It feels more like trying to cross a massive suspension bridge that is missing half of its tension cables. The bridge is structurally standing, but without those cables, without the myelin and the proper cytoskeletal tone, the entire structure sways violently with every single step.
That is a highly accurate biophysical metaphor. Every attempt to roll over, to transition from lying to sitting, to pull up to a stand, or to manipulate a toy requires the child to actively, consciously tense muscles that neurotypical individuals fire involuntarily.
We don't even think about sitting up.
Exactly. For them, it is an exhausting, conscious battle against gravity.
So when a physical therapist or an occupational therapist works with a PRA child, they're essentially trying to retrofit that swaying suspension bridge,
That's a great way to put it.
earning just a little more core strength so the child can sit upright in a specialized chair without slumping over, which then allows them to free up their hands to use their AAC device. That is an astonishing victory of biomechanical engineering.
And maintaining that fragile stability requires intense vigilance because there are severe long-term medical hurdles that directly threaten that hard-won progress.
Right.
Two of the most prevalent and disruptive are epilepsy and orthopedic complications.
Let's tackle the epilepsy first, because it is incredibly common. The literature notes that seizures affect approximately 50% of patients with PURA syndrome, typically beginning in infancy or early childhood. Why is the brain so susceptible to electrical storms without Pur Alpha?
It relates to the balance of excitation and inhibition in the developing brain. While the exact downstream mechanisms are still being heavily researched, the lack of Pur Alpha significantly disrupts the maturation of neural networks, potentially impairing the development of inhibitory interneurons.
Inhibitory meaning the brakes.
Exactly. Without enough inhibitory signals to calm the system down, the cortex becomes hyperexcitable. Random electrical misfires can quickly cascade into a full-blown seizure.
And the data shows these aren't always easily controlled. They are often drug-resistant, requiring complex pharmaceutical cocktails. The 15-year-old case study we reviewed specifically highlighted the use of valproic acid. How exactly does a drug like that work to stop a seizure in a brain lacking Pur Alpha?
Valproic acid works on multiple fronts, but primarily it acts to increase the levels of GABA in the brain.
GABA.
GABA. Gamma-aminobutyric acid is the primary inhibitory neurotransmitter. It essentially acts as a chemical brake pedal.
Okay, so it steps on the brakes.
Right. By artificially boosting GABA, the medication helps suppress the hyperexcitability of the cortex, forcing the electrical storms to quiet down.
Why is achieving that seizure control considered one of the most critical medical inchstones for a family? I mean, obviously a seizure is physically dangerous in the moment, but neurologically, what is at stake?
What is at stake is the child's developmental progress. Uncontrolled seizures pose a massive risk of developmental regression.
Regression. Losing skills.
Yes. If a child has spent 3 years painstakingly building a fragile myelinated neural pathway to allow them to sit up or use a communication device, a prolonged electrical storm can literally strip the insulation right off those nerves. It damages the synapses.
That is heartbreaking.
It is. Families frequently report their child losing hard-won skills following a cluster of severe seizures. So achieving pharmaceutical control of the epilepsy is not just about immediate physical safety. It is about defending the child's developmental milestones from being erased.
Wow. And while you are fighting the neurological storms, you also have to fight the biomechanical breakdown of the body as it grows, because the most common orthopedic issue cited in the literature is scoliosis.
Yes, scoliosis or curvature of the spine. It occurs in about 48% of cases, becoming particularly pronounced as the child enters their teenage years and experiences rapid bone growth.
This goes right back to the suspension bridge analogy, doesn't it?
It does perfectly. The human spine is basically a stack of bones that relies entirely on the surrounding trunk muscles, the tension cables, to hold it perfectly straight.
Right.
When a child has persistent, severe hypotonia, those trunk muscles lack the necessary strength to fight gravity hour after hour, day after day. As the child grows heavier and taller, the asymmetrical weakness causes the spine to slowly buckle and curve.
The 15-year-old case study from the Frontiers Journal featured X-rays showing severe spinal curvature directly resulting from this long-term hypertonia.
Exactly. It's a progressive issue.
So an Inchstone in this arena isn't necessarily walking. It might be the child successfully tolerating a rigid custom back brace for a few hours a day to delay the need for spinal fusion surgery. It is a relentless, exhausting marathon for the child.
And the burden of managing this marathon, the medical appointments, the therapy sessions, the pharmaceutical regimens, it does not just fall on the clinical team. It falls squarely on the shoulders of the parents, which inevitably leads us to one of the most practically demanding aspects of this entire journey, forcing the system to provide support.
Yes, the administrative gauntlet. We have established exactly how monumental these small biological, communicative, and physical steps are. We understand the complex molecular mechanisms underlying the hypotonia and the speech delays, but how do you translate that complex molecular biology into language a school administrator or a local bureaucrat will actually listen to when you are fighting for educational funding?
It's a totally different language. If you're listening from England, this process is formalized in the EHC plan, the Education, Health, and Care Plan, and the battleground is the annual review.
Let's pause and just acknowledge the psychological reality of sitting in that room. You are a parent who has spent the last 364 days fundamentally shifting your mindset to celebrate a thumb wiggle, to validate a mumble as speech, to view your child's survival as a triumph.
You've rewired your whole perspective.
Right. And then, once a year, you are legally mandated to sit in a sterile room surrounded by professionals whose entire administrative purpose is to focus on your child's deficits. You have to read cold clinical reports detailing every single thing your child cannot do, just to prove they are disabled enough to deserve help. The emotional whiplash of that is staggering.
It is incredibly traumatic for families. To survive it and to effectively advocate, you have to execute a tactical mindset shift. You must view the annual review not as an evaluation of your child's human worth, but strictly as a legal negotiation for resources governed by the SEND Code of Practice.
It's a business meeting.
Yes. The statutory framework dictates this review must happen every 12 months or every 3 to 6 months for children under 5. Preparation is the only defense.
Okay, let's break down the strategy. The EHC plan is divided into sections, but 3 are absolutely paramount. Section B, Section F, and Section E.
Correct. Section B outlines the child's special educational needs. Section F details the provision, the actual tangible support they will receive to meet those needs. And Section E details the outcomes, the goals we are hoping to achieve.
So B, F, and E.
Yes. And the entire legal strength of the document relies on the inextricable link between Section B and Section F. Every single need identified in B must have a corresponding legally binding provision in F.
So how does a parent weaponize the Inchstone mindset in this room? How do they use what they observe at home to demand funding?
You use your documentation as hard, incontrovertible evidence. We discussed earlier that PURA children have a massive gap between receptive understanding and expressive speech.
Right, they understand but can't speak.
You know your child understands. But an educational psychologist might observe them for 20 minutes, see them sitting silently, and mistakenly assess them as having profound cognitive impairment requiring minimal academic intervention.
You have to prove the cognitive capability to them.
Exactly. You keep a diary. You capture video. That moment your child successfully navigated the tablet screen to ask for a drink. Bring that video to the meeting.
Show them the marathon.
Yes. Use it to legally prove in Section B that the child possesses receptive language and intent to communicate, and therefore, in Section F, they require the provision of specific, high-tech AAC devices and the training to use them.
But local authorities are notorious for trying to avoid legal financial commitments by using what advocates call weasel words, or vague language in Section F.
Oh, vague language is the absolute enemy of rare disease support. If the draft plan provided by the local authority says your child will receive access to speech therapy or opportunities to use an AAC device, that is legally meaningless.
Because access to could just mean there's a therapist in the building.
Exactly. Access to cannot be legally enforced if the school's budget is cut.
So how do you force them to change it?
You must demand statutory specificity based on professional recommendations. You do not accept access to. You demand language that specifies exactly what, how much, how often, and by whom.
Give me an example of the right wording.
It needs to read, 45 minutes of direct, 1.1 intervention by a qualified HCPC registered speech and language therapist once per week, utilizing a PODD communication book. If it is quantified, it is a legal mandate.
But the local authority won't just take a parent's word for it. You need the professional reports to back up that demand. What if the school hasn't done the assessments?
The SEN Code of Practice is very strict on timelines. The school or local authority is legally required to request updated reports from therapists, psychologists, and medical professionals. Crucially, these reports must be circulated to the parents at least 2 weeks before the annual review meeting.
So don't let them hand you a report as you walk in the door.
Do not walk into that room blind. If you are 2 weeks out and have not received the bundle of reports, you contact the SNCO immediately and demand them.
You also need to know the timelines post-meeting because bureaucracies thrive on delays.
They certainly do.
After the meeting concludes, the local authority has exactly 4 weeks to issue a decision letter stating whether they will maintain the current plan, amend it, or cease it. If they agree to amend it, they must issue the final, legally binding amended plan within 8 weeks of that decision. That is a total of 12 weeks from the date of the meeting.
And what if they refuse to include the necessary provisions? If they refuse to fund the AAC device or the 1.1 support?
You have the right to appeal. You have 2 months from the day of the decision letter to lodge an appeal to the SIN tribunal. It sounds terrifying, but parents need to know that historically, the vast majority of appeals to the tribunal are decided in favor of the parents. The law is designed to support the child's needs, not the local authority's budget.
Beyond the legal battle over therapy minutes, there is one incredibly empowering tool within the EHC framework that the SN4U guide emphasizes. And that is centering the child's voice through the All About Me section.
This is so important for a child who is nonverbal. Because how do you center the voice of a child who literally cannot speak?
You translate their nonverbal cues into legal requirements. The parent acts as the interpreter. You know your child better than anyone on earth. You know what makes them smile, what causes them anxiety, what triggers a sensory meltdown.
Right.
If you know that a loud, chaotic, brightly lit environment causes your child to become overwhelmed and engage in hand flapping or self-injury, that information goes directly into the All About Me section.
And how does that help with funding?
Because it is documented there, it legally dictates that Section F must provide a quiet, low-arousal learning environment or a designated sensory break room. Their physiological reactions become statutory mandates.
Which is an incredibly powerful way to advocate. But let's be deeply honest here. Acting as a translator, an advocate, a nurse, a physical therapist, and a legal negotiator day in and day out, it is exhausting.
It's beyond exhausting.
It takes a massive cumulative toll. Which brings us to the caregiver's journey. We need to talk about what happens to the parent.
We have to address the behavioral realities of PURA syndrome, particularly as these children age, because behavior directly impacts caregiver burnout.
Yeah.
The clinical literature notes a very distinct, beautiful behavioral profile for these children. They are overwhelmingly described as having a loving, friendly, and highly social disposition. They inherently want to connect with the people around them.
They really do. But as they grow, particularly as they reach their teenage years, the harsh reality of their biological limitations collides with their desire to connect.
It creates a perfect storm.
Think about what is happening inside that body. You have a teenager experiencing all the typical hormonal changes, the complex emotions, and the desires for independence that any teenager feels. But they are trapped in a physical body with the expressive capability of a toddler.
Exactly.
They cannot verbally explain why they are angry, they cannot ask complex questions, and due to their motor delays, they literally cannot walk away from a situation that frustrates them or causes sensory overload.
That intense biological frustration has to go somewhere. The literature documents that the inability to communicate distress frequently manifests as severe anxiety, particularly when routines change or sensory environments become overwhelming.
So how do they cope?
To self-soothe or to gain proprioceptive feedback when their cortex feels overwhelmed, they may engage in intense sensory-seeking behaviors, like hand-flapping or mouthing objects. And in severe cases of frustration, that lack of expressive outlet can result in self-injury, like hand-biting, or aggression toward caregivers.
Managing a self-injuring teenager who is now bigger and physically stronger than they used to be, while simultaneously managing their G-tube feeds, monitoring them for seizures, and fighting the local authority for educational funding, is a recipe for total, all-consuming caregiver burnout.
Which is why we have to address caregiver stress biophysically, not just emotionally.
What do you mean biophysically?
Chronic stress actually alters the caregiver's biology. It triggers the HPA axis, the hypothalamic pituitary adrenal axis, flooding the parent's system with cortisol.
The stress hormone.
Right. Sustained long-term cortisol exposure degrades the caregiver's immune system, it disrupts their sleep architecture, and it impairs cognitive function.
So when advocates say you have to put your own oxygen mask on first, it's not a platitude.
It is a clinical necessity. Caregiver self-care is not a luxury. It is not a spa day. It is a fundamental requirement for the long-term, sustainable management of a child with a complex, rare disease.
Yeah.
If the caregiver's physiological or psychological systems break down, the entire medical and educational support structure for the child collapses.
But the profoundly beautiful news in this story is that the parents who received those early diagnoses back in 2014 and 2015 realized this immediately.
They absolutely did.
They looked around, saw that the medical establishment had no roadmap for them, and realized they had to build the lifeboat themselves. And they did exactly that. They built incredibly robust, fiercely organized global support networks.
The organizational power of the PURA community is phenomenal. The PURA Syndrome Foundation globally, alongside specific regional powerhouses like the PURA Foundation Australia, directed by Mel Anderson, have entirely reshaped the landscape for newly diagnosed families.
They really have.
They do not just fund high-level research. They provide the granular, practical, day-to-day emotional support that a clinician simply cannot offer.
And they recognize that a rare disease doesn't just happen to the child. It happens to the entire family ecosystem. They have specific outreach programs for grandparents and siblings.
Because a sibling growing up in this environment needs specialized support to understand why their brother or sister requires so much medical attention, why they can't play like typical kids, and how to process their own unique grief and anxiety.
But perhaps the most astounding achievement of these foundations is their direct impact on hard scientific research. They are not merely support groups, they are the actual engines driving clinical science forward.
It's true. Look at what they've accomplished in just a decade. October 23rd, the anniversary of that first publication, is now officially recognized globally as PURA Syndrome Awareness Day.
But even more tangibly, the parent community literally funded the creation of the PURA mouse for research in Australia, collaborating with researchers like Professor Christopher Reed at the Florey Institute.
Let's explain what that actually means, because it is a monumental achievement. A PURA mouse is what biologists call a knockout mouse model.
A knockout mouse.
Yeah, scientists use genetic engineering to specifically knock out or mutate the PURA gene in a line of mice, replicating the exact haploinsufficiency seen in human children.
Why do they need a mouse with PURA syndrome?
Because you cannot safely test experimental high-risk interventions on human children. By having a genetically matched animal model, researchers can study exactly how the brain develops without Pur Alpha in real time.
So they can test drugs on them.
Yes. They can test massive libraries of existing pharmaceutical drugs to see if any of them alleviate the epilepsy. And most importantly, the mouse model is the absolute prerequisite for developing preclinical gene therapies.
Parents raising money so scientists can breed specialized mice? It is the ultimate example of a family community taking aggressive control of the scientific narrative.
It is empowerment in its purest form.
It really is. So let's take a breath and trace the arc of the journey we have taken today. We started at the absolute molecular foundation, understanding the reality of haploinsufficiency, that single, exhausted conductor trying to orchestrate the immense complexity of neural proliferation and myelination.
We examine the physiological gauntlet of the neonatal phase, recognizing that surviving central apneas and hypothermia is not merely passing time, but a profound victory of maturing brainstem fighting to build life-sustaining autonomic pathways.
We dove into the neurology of the receptive expressive gap, validating that the inability to articulate speech due to dysarthria in no way diminishes the child's complex cognitive understanding, and how high-tech AAC devices finally unlock their true voice.
We outlined the biomechanical reality of gross motor delays and the wide-based gait, the critical necessity of pharmaceutical seizure control to protect myelination, and the constant orthopedic vigilance required to manage scoliosis.
We broke down the tactical strategies for surviving the EHC annual review, detailing exactly how to translate your daily Inchstones into the hard, undeniable evidence required to force bureaucracies to provide legally binding educational support.
And we acknowledged the heavy, cumulative biological and psychological toll this journey takes on the caregiver, while highlighting the incredible research-driving power of the global PURA support community.
So as we close this deep dive, I want to leave you with one final thought to process. We have spent this entire time focusing on your individual child, validating the profound biology behind their micro-victories. But I want you to step back and consider the massive global Inchstones that are happening right now, specifically because of you.
The future of genomic medicine relies entirely on data. By participating in global patient registries, by donating biological samples to biobanks, and by meticulously logging your child's symptoms, you are the ones generating that data.
When you document that strange temperature instability, or record the exact frequency of their hiccups, or track how their seizures respond to valproic acid, you are not just managing your child's daily care. You are providing the critical, raw clinical endpoints that scientists desperately need.
You are literally drawing the map in the dark.
Clinical researchers and geneticists are using your diaries, your videos, and your observations to build the plausible mechanism pathways that regulatory agencies like the FDA or the EMA require before they will ever approve a clinical trial for a new treatment.
Every single Inchstone your child achieves, and every data point you share with the global foundations, is laying the structural groundwork for future preclinical gene therapies.
By simply loving and observing your child, you are actively rewriting the future of human genomic medicine for the next family who receives this diagnosis in a sterile clinic room.
Your daily reality is the foundation of tomorrow's science.
It is a profound, world-changing legacy, so thank you. Thank you for your incredible resilience. Thank you for doing the hardest, most complex job in the world with such fierce, unrelenting love. When you look at your child today, I want you to completely discard the typical developmental charts of the outside world.
Throw them away.
Think back to that murky diagnostic x-ray we talked about at the beginning. It doesn't matter that it's not a clean, simple line. You understand the biophysics of the murky waters now. When your child presses that AAC tablet or holds their head up against gravity, know that they just moved a biological mountain.
Celebrate the thumb wiggles today.
Validate the mumbles. Acknowledge the sheer monumental effort behind the Inchstones. We see exactly what it takes. We validate your science and your struggle, and we will be right here waiting to dive deep with you again next time.